Hello, now we are going to look at what's called indices equations. So equations where the variable, the thing we don't know, is an indice, is a power of a number. So here we have 8 to the power of 3. We're going to be dealing with situations where we have an x, an unknown, up as this power of 3, or this indice 3, or this exponent 3. So we're going to have, our method is going to be to try and get the same base number on both sides of our equation, and then we're going to be able to look at making the indices equal to each other and create a new equation that we can more easily solve, because we don't know how to directly solve a problem like this where we have our variables up in the powers, but we can solve them in a roundabout way. And we'll start out by looking at this situation here where we have 3 to the power of x is equal to 3 to the power of 2. If we think about this, there's only one power that x could be that would make it the same as 3 to the power of 2. X would have to be equal to 2. If x was equal to any other number, this equation, this equality, couldn't be true. So what we can say is this implies that x must be equal to 2. Because 3 to the 2 is the only thing that would be the same as 3 to the 2. So if we can create this situation where we have the same base numbers equal to each other, then we must be able to equate, we must be able to equal the powers. So this equation is not the same as this equation, but it implies that this must be true. So the only power of 3 that would be the same as 3 to the 2 is 3 to the power of 2. So that's how we can get an equation that we can actually solve, that we can get a value for x for. Here we have 2 to the power of, to the indice of, 5x is equal to 2 to the power of 15. Well, there's only one power of 2 that must be the same as 2 to the 15. That's going to be 15. So 5x must be 15. And now we have an equation that we know how to solve in order to get x. We divide both sides by 5 in order to end up with x must be equal to 3. And we could double check that. We could sub back in 2 to the power of 5x when x is 3 would be 2 to the power of 5 by 3 is 15. So we end up with our correct value. I'll rewrite that a bit bigger. Again, x being 3 must be true because that's the only way that we would end up with 2 to the 15 is equal to 2 to the 15. 2 to the power of 15. Now what do we have to do here? Because we don't have something like our original situations where we had the same base number so we could equate the powers. Well, in this situation we have to try and get to something like this. Can I write both of these to the same base number? Well, I can immediately see 25 is 5 squared. It's 5 to the power of 2. So what I can do is say 5 to the power of x would be equal to 5 to the power of 2, because 5 to the power of 2 is 25. And at that point, I'm back to my easier situations from before, my beginning situations. Now I can say, well, the only power of 5 that would be the same as 5 to the power of 2 is 5 to the power of 2. So x, therefore, x must be equal to 2. It's the only value of x that would make this equation true. Here we have a little bit more rearranging to do, but it's the same type of logic. If we see that we have our unknown as a power, then we're going to try and rewrite both sides of the equation to be the same base number is equal to the same base number, and then we can equate the powers. So we have 2 to the x, and we can say we have an eighth. Well, I know 8 is 2 to the power of 3. So let's start off by doing that. Write everything in terms of the same base number as quick as you can. And from there, rearrange. So now we have base 2, but I don't have 2 to the power of something is equal to 2 to the power of something because this is underneath the line. But I know if I move this up on the top of the line, all I have to do is create a negative power. So I'm using all of these tools that I know are available to me. And now I have 2 to the power of something is equal to 2 to the power of something. Well, that means my 2 powers must be the same. So x can only be minus 3. That must be true. Now here I have 9 to the power of x is equal to 27. This is more difficult because I don't know what power. Ideally what I'd like to be able to do is write down 27 is some power of 9, but I don't have a good picture as to what 27 is as a power of 9. So I have to think more carefully now. And what I can say is, well, I can write 9 as 3 to the power of 2, and I can write 27 as 3 to the power of 3. So I can write both of these numbers as powers of 3. And that will mean that I can get the same base is equal to the same base and then equate my powers. So let's do that. We have 3 to the power of 2 to the x. Remember, all of this is to the power of x. So 9 is the same as 3 to the power of 2, or 3 squared. So I have 27 to the power, 27 as a power of 3 is just 3 to the power of 3. So I have a power on my bracket here. So this is going to be 3 to the power of 2 times x, which is 2x. So power on the bracket means we end up multiplying our powers. So we end up with 3 to 2x is equal to 3 to 3. Well, that means that 2x must be equal to 3. This implies that 2x must be equal to 3. And now we solve that equation in order to get x is equal to a number. So x must be equal to 3 over 2. That's the only way that I could get this equality or this equality to be true. Now here, I can see that I would be able to write 2, 4, and 8 all as powers of 2. So I'm going to try and write everything as powers of 2 and then get 2 to the power of something is equal to 2 to the power of something and equate my powers. So 2 to the power of x is fine. Don't need to do anything with that. 4 is 2 to the power of 2. Now, square root means the power of 1/2. So I'll do that in 2 steps. 2 to the power of x is equal to 2 to the power of 2 on 2 to the power of 3 is 8. 2 by 2 by 2 is 8. And now I have a power on the bracket, so I can multiply the powers. And I have to do this first. So just like bin does, I have to do my indices work, or I have to do my brackets work before I do anything else. So I have 2 to the power of 3 times 1/2. 2 to the power of x is equal to 2 to the power of 2 on 3 times 1/2 is 3 over 2. So 2 to the power of x is equal to, I have the same base numbers here multiplied together, so I can add my powers. So this is 2 to the power of 2 plus 3 all over 2. Now I can add these two fractions together. So this is, sometimes it can be nice to write this off to the side because it can get a little bit messy. So I have 2 plus 3 all over 2. I need to get the same base. So I need to multiply this number by 2 over 2. So I end up with 4 all over 2 plus 3 all over 2. So I end up with 7 all over 2. I can now add the numerators and I end up with 7 all over 2. So 2 to the x is equal to 2 to the 7 all over 2. And therefore, x must be equal to 7 over 2. It's the only value for x that would make it work. And I can get situations like this. And as with any complicated looking question in maths, all we do is do a little step at a time. 8 is the same as 2 cubed, power of 1/2 is the same as square root, and so on. So we just deal with this step by step. So I can't see that I can write all of these as powers of 4, but I could write all of these numbers as powers of 2. So I'm going to rewrite this all as powers of 2. So I have 4 is 2 squared, power of 3x minus 1. cube root means power of a third. Make that a 16. So change one thing at a time. 8 is the same as 2 to the power of 3. Anytime there's anything complicated going on, always use brackets just so we don't get anything confused. So I have a power on the bracket. So all of this, 3x minus 1, all of that is the power on this bracket. So all of this gets multiplied by the 2 here. So 2 on 3x minus 1, all of that. 16 is 2 to the power of 4. Again, you can check this kind of stuff on your calculator. If you're unsure of that, you can see or you figure out by using your calculator, or that you can write all of these as powers of 2 and then double check what you're doing as you go. So is 16 the same as 2 to the power of 4? Double check as you go. There is no problem with doing that. Multiply out this bracket. So we have the powers that we're multiplying out here. So we end up with 6x minus 1. We are multiplying our powers here because we have a power on the bracket. Power of 4 times 1/3. It's by going slowly, step by step, that we can keep track of everything. Now all I'm dealing with is multiplying 4 by 1/3. That's all I'm concerned with for the next line I'm writing. To the power of 4 times 1/3 is 4 over 3. And now I have the same base numbers here I can subtract. 2 to the power of 4 over 3 minus 3. This would get a little bit messy to write out, so I'm going to effectively do it as an aside. So let's do this sum. So I end up with minus 5 over 3. 4/3 minus 9/3 ends up being minus 5/3. So I have 6x minus 1 is equal to 2 to the minus 5 all over 3. And at this point I have 2 to the power of something is equal to 2 to the power of something. So these two powers must be equal to each other. So now I have an equation in x that I'm able to try and solve. So I'm going to add 1 to both sides and simplify. Or actually, I am going to multiply both sides by the lowest common denominator to get rid of my fractions, because this is complicated enough that it is wiser to do that. So I end up with 18x minus 3 is equal to minus 5. 3 divided by 3 is 1. Now I can rearrange and simplify. Pardon, I just noticed I made an error. I was multiplying out this bracket and I need to multiply everything in the bracket by 2, and I did not. So I'll change that. This is a good opportunity to highlight again, never skip steps. Always show yourself exactly why you're doing what you're doing, because in a complicated question like that, a slip like that is very easy to make if we aren't very careful with how we lay out everything that we do. Now, continuing to solve, we end up with add 6 to both sides, and we end up with 18x is equal to 1. Divide both sides by 18. So x must be equal to 1/18. So as my slip up ably demonstrates, we need to take our time with these questions and slowly change one thing at a time. Doing lots in a single line is tempting because we can see how long this question takes. But if we skip steps, the chances of making an error like that are very high. But by doing things slowly, step by step, we minimize the chances of making a mistake, even in a complicated question like this. And that is what we need for now.